Good morning. This is Unlock Circuits 18EC42 Module 2 Lecture 2 MOSFET Internal Capacitance and High Frequency Bonding. This is what we have studied in the last two videos, and we'll be taking up the exercises in this video. Now, if you see over here, we have considered two examples in this, which we have written as 9.3 and 9.4. For this, we need to use the formulas written over here and solve them. So basically, it just means we need to find out the capacitances and then the GM, and then once we found the capacitance and GM, we can find the value of FT also. So going to the problems, the two problems here. So you can see what we have mentioned here for a N-channel MOSFET with TOX equal to 10 nanometer, L equal to 1.0 micrometer, and W is equal to 10 micrometer, L OV equal to 0.05 micrometer, CSB and CDB 10 picofarad and femtofarad, and V0 is equal to 0.6 volts, VSB equal to 1 volt, and VDS equal to 2 volts. We need to find out the different capacitances. And the same thing we have listed over here. And first COX is what we need to find out. And this COX is epsilon by TOX, where epsilon is the permittivity. Epsilon is nothing but epsilon or epsilon naught, and that is 3.9 into 8.854 into 10 to the power of minus 12. The epsilon r for the silicon dioxide is 3.9. That's not given in the problem, but that is to be assumed. And the value of epsilon naught is the standard value, that is 8.854 into 10 to the power of minus 12. TOX is 10 into 10 to the power of minus 9. And if you try to find out this, then this will be 3.45 into 10 to the power of minus 3 farad per meter square. Now here what is mentioned is in terms of the femtofarad per micrometer square. Femto is 10 to the power of minus 15. Micro is 10 to the power of minus 6. Square of that is 10 to the power of minus 12. So 10 to the power of minus 15 by 10 to the power of minus 12 will give us the same thing, 10 to the power of minus 3. So COV is WLOV into COX. W is the given value here, and the LOV value is given here, COX. We have found out just now, and then if you substitute over here, you'll get the value as 1.72 femtofarad. Then the value of CGS is 2 by 3 WLCOX plus WLOV COX. So this we have already found out here, 1.72, same thing is substituted here. And this is the 2 by 3 of WL, and COX we have found out here as 3.45, and that is same thing is being mentioned over here, and hence we'll get at the end 24.7. Then once we calculate this, then we'll get here as, CGD also will be the same value as the, 1.72, same formula here as well as here. CGD is COV itself, and hence we'll get 1.72. CSB is CSBO formula is this, and you can put here 10 femtofarad divided by root of 1 plus VSB is 1 and V0 is 0.6. Then if you try to calculate, first divide this and calculate the value, and then add to 1 and then take the root, and then divide this by whatever value you got here, you will get 6.1 femtofarad. Similarly, CDB is what you can find, and that will be the value wherein only the VDB is different, and that is 2. Therefore, this will become 4.1 femtofarad. Next problem is calculate FT for the N-channel MOSFET whose capacitances were found in the earlier exercise. Assume the operation at 100 microamperes. This is the ID value with K dash value 160 microamperes per volt square. So FT is what we need to find. The formula for FT is given over here. GM by 2 pi CGS plus CD. And GM we don't know, so GM is 2ID by VOV, or you can write root of 2 kn dash w by l id. So 2 you know, kn dash you know, w by l you know, and then id you know, 100 micrometers. So if you try to calculate for this, you'll get 65.6 microampere per volt. Substituting this value over here, because that is gm there, divided by 2 pi, 24.7 plus 1.72 multiplied by 10 to the power minus 15 will give us 3.4 gigahertz. Thank you.